ASME PCC2, repair of pressure equipment and piping. In this module, you shall learn about these articles 201, 202, 209, 210, 211, and until 502. So we go one by one. Expect around 7 to 8 questions from this document. And we shall quickly explain the highlights of these articles from PCC2. We have also brought 6 sets of flashcards and also 100 mock questions. But please read these because this is mostly going to be an open book question, so you should know where to find them. So have a look at the PCC2 yourself. With emphasis on this highlighted that the flashcards that we brought for you. Now, Article 201 is butt welded insert place in pressure components. It involves partial replacement of pressure parts by full penetration butt welds, and replacement of entire component is not considered in this repair method. So you should know the scope of this 201. Insert place shall be compatible with original material and operating condition, but need not be of similar material, but should at least have equal notch toughness and allowable stress. If ASME material are used, the replacement material should have the same ASME P number. So it should be the same P number, so you can use the same WPS for air welding. Insert plate thickness should not be less than the nominal thickness of the material it welds into, otherwise referred to construction code. So it should not be less than the nominal thickness. Rectangular and square insert plates should have a from 1.5 inch to 1 inch thick, should have rounded corners of 3 inch. And if it's more than 1 inch, then the rounded corner should be 6 inch. This could be all potential exam question. Non-post weld heat treated butt welded carbon alloy steel insert place shall be the less than the 12T or 15 inch. Make sure the overall structure is not twisted when cutting out a section. Use temporary support if needed. This is common sense. Insert plate toe should be at least 6 inch away from the nearest nozzle. And for nozzle greater than 12 inch, the distance from insert plate shall be twice side diameter of the nozzle. This can be like copied to a calculation type of question. But you should know that for nozzle, if it's more than 12 inch, then the distance from insert plate shall be twice the outside diameter of the nozzle. And perform full UT or RT or MTPT on both sides of existing butt weld at least 4 inch from each side of the intersection with insert plate. And bevel angle 55 degree to 35 degree before inserting a doghouse insert plate with or without nozzle. Taper transition shall be 3 inch, shall be minimum 3, 1 to 3 if or 3 to 1 if the insert plate thickness is more than the original thickness. So it should be tapered 3 to 1. And you can see here, this should be minimum 6, greater than 6 inch. And this is a doghouse, so you should know where to find this. The weld between insert plate and the existing pressure components shall be a full penetration butt weld. This is repeated twice in this article, so this could be a potential exam question. And preferably double welded butt joint should be used. So oil, grease, paint, scale, other foreign material should be removed from the area adjacent to a weld. That's because it can, make the weld defective, and the sufficient distance away from the weld to avoid contamination. Short circuit mode of gas metal arc is not recommended because it's very prone to lack of side bulb fusion. Reduction of thickness due to grinding shall not exceed 0.8 millimeter or 1 by 32 inch or 10% of the nominal thickness. This is the same requirement that ASME section 8 also wants, or ASME section 2 as well, where the material thickness should not be less than 0.8 millimeter of nominal thickness. Final thickness shall never be less than the required thickness. So that is, the required thickness means the design thickness here for the calculation, excluding corrosion allowance. The distance between butt welds shall be minimum 8 inch, else possible heat treat. This can be also a potential exam question. Intersecting insert plate and existing butt welds should be avoided where possible. Otherwise, the angle should be minimum 30 degree, preferably 90 degree. The reason it's 90 degree is that to quickly, as little as length, they are crossing each other, the insert plate and existing butt welds. But minimum should be 30 degree and preferably 90 degree right angle. You can quickly pass through. There shouldn't be too much of length of intersection here. UT is used. Examination of root pass by either magnetic particle or PT is recommended. So do a MTPT of the root pass, and then once the weld is completed, then do a UT. Separate leak test. Visual bubble forming sniffer may be desirable to check for leaks before pressurizing the component to the maximum test pressure. And all testing and inspection should be performed prior to application of insulation or coating, because the coating and insulation can mask, especially during leak test or tightness test. Article 202, weld build-up procedure can be used to structurally restore steel, but not when a crack is observed or pipe is blocked or liquid filled. So you can build up the thickness by welding it, but not when there is a crack, because the crack can break through that. So that crack needs to be removed, and the tip needs to be first blunted by drilling at the ends, or the crack totally removed and tested, and make sure that the crack is removed, like MTPT tested after removal of the crack. Nominal chemistry of the deposited weld metal shall match the base material and with a tensile strength equal or greater than the base metal. So this is also common sense. The weld shall extend minimum distance of B in each direction beyond the affected base metal, where B is 3/4 of under root R T nominal, and R is the outer radius of component, and T nominal is the wall thickness of the component. So there can be a question, a calculation type of question, and you have to use this formula. The weld edge shall be tapered maximum at 45 degree to base metal. Could be a potential exam question. Weld corner shall not be more than weld thickness. Two adjacent weld build-up shall have a minimum distance of, again, the same thing, B 3/4 of the square root of R T nominal. Thickness of weld build-up shall not be more than the thickness of pressure component. And the proof test qualification may be performed through a burst test mock-up. That means you weld the test sample, and then you pressurize it until it bursts, and then find the ultimate strength of that. Prior to build-up, RT or UT, the entire surface to ensure no crack exists. Surface shall be cleaned by acetone and free from rust, scale, paint, coating, or other contaminants. So that is to prevent the weld being affected by these contaminants. It's necessary to minimize penetration during the first layer, and thus a smaller diameter electrode should be used, so there is no underfill or lack of sidewall fusion, and then you have a better access if you use a smaller electrode. The electrode side of the first pass should not exceed the remaining base material wall thickness. So this could be a potential question. This is a reference. Build-up welding shall be performed using a qualified groove welding procedure as per ASME section 9. So the welding procedure is as per ASME section 9. Typical welding process for these repairs include shielded metal arc welding and gas tank solar welding. The reason is that they are very you can have much more control when you are doing this manual type of welding. Temper bead welding technique may be used on carbon steel or alloy steel to avoid post-weld heat treatment. Now, temper welding is the subsequent pass, actually using the heat of the previous pass. So you are decreasing the thermal difference when you are welding, and the bead overlap of 50% should be maintained to reduce the potential for burn through. First weld pass should be around the outer perimeter, and then you work your way inside to provide an outer gauge for the welder. An edge angle of 30 degrees is recommended, and wall thickness of weld bead depth is measured by UT thickness measurement, and volumetric NDT may be performed in place of pressure testing when pressure testing is not practical. All testing and examination shall be performed prior to application of insulation coatings, as always, because the coating or insulation can mask it and you cannot visually observe. And as you can see, this is a weld build-up, and these are all the dimensions they give, how that works, and the angle that it should be, the 45 degree. And as you can see, the thinning, the overlapping the B of the thinned area that you are building up, like reinforcing it. Alternative to post-weld heat treatment that is applied to ferritic welds and welded components. They are applied because to reduce the high level of residual stress, provide tempering to reduce the stress, and to diffuse hydrogen if resistance to hydrogen sulfide or stress corrosion cracking is a service requirement. So you should know what are the purpose of post-weld heat treatment: reduce stress, relieve stress, and reduce hardness. We should ensure that without post-weld heat treatment, the repair weld does not exceed certain hardness limit. Many codes of construction or post-construction codes permit use of elevated preheat as an alternative to performing post-weld heat treatment. So you can use preheat, but under terms and conditions. Tempering of weld deposits may be accomplished by implementing a special welding sequence and techniques. And Article 210, in-service welding onto carbon steel pressure components or pipelines. And this article addresses the requirements and precautions associated with welding onto pressure components while the system is still in operation. So you should know the scope of this. So when they say this system is in operation while you are doing weld repair, then it's Article 210. This article excludes welding onto stainless steel, alloyed steel, or non-ferrous material. So it's just carbon and low alloy steel. An adjustment in flow during in-service welding may increase hydrogen cracking risk or burn-through risk. There are two primary concerns when performing in-service welding. First concern is burn-through, also referred as blowout. A burn-through occurs when the unmelted base material under the weld pool loses the ability to contain the contents of the pressure components or pipeline, allowing the content to be expelled. So practically when you're welding and there is, if there is not enough thickness to withstand, because a part of the thickness is actually being melted or too heated up and the strength is reduced. So the remaining part, I mean, at that temperature, normally when you increase the temperature, the strength of material reduces, very high temperature. So, the available thickness at that temperature cannot withstand the temperature. So you might have a burn through. Welding onto pressure components or pipelines with thin walls like 4.8 millimeter or 0.188 inch or less is possible as long as precautions taken. And these include controlling the heat input or penetration of welding process using a smaller diameter electrode. So these are the two options that you can use to control the heat. Second concern is hydrogen cracking. And hydrogen cracking occurs when tensile stresses are acting on the weld hydrogen present in the weld, and when the weld solidifies, the resultant weld microstructure is crack susceptible. So there are three options here, three parameters for hydrogen cracking to happen. One is a tensile stress, one is presence of hydrogen, and then the microstructure when the weld solidified, resultant is microstructure. Weld microstructure is could crack. So any of these three conditions eliminated or reduced, then hydrogen cracking will not occur. The most common in-service welding practice used to reduce hydrogen cracking concern is using obviously a low hydrogen welding process. So you're reducing the amount of hydrogen, and a welding procedure that reduces susceptibility of forming a crack susceptible microstructure. Use of preheat, another technique that commonly used to reduce the susceptibility of forming a crack susceptible microstructure. When welding onto a pipeline less than 6.4 millimeter or 0.25 inch thick, it may be necessary to reduce the welding heat input to lower the probability of burn through. However, the lower welding heat input could result in weld microstructure. An in-service fillet weld procedure is defined as a procedure that's used to join additional material onto the in-service pressure components or pipeline to reinforce the damaged area, such as full encirclement sleeves and patch plate repairs. And in-service weld metal buildup procedure is defined as a procedure that is used to deposit weld metal onto the surface of pressure components or pipeline to reinforce a thinned area, such as metal loss due to corrosion or erosion, and a change in the range of welding current used in the procedure qualification or specified in the welding procedure shall require requalification. So these are essential parameters and requires the requalification of welding procedure. Visual examination of macro section test samples shall show complete fusion, no cracks, no undercut more than 0.8 millimeter or 10% of wall thickness, and a minimum of 5 weaker hardness indents. So this could be how many hardness tests you should do. Using a 10 kg load shall be made in coarse grained heat affected zone in the Haas region of the weld toe. Visual inspection of nick break test sample fracture surfaces shall show complete fusion. And wet hydrogen cracking is a concern, and in-service weld should be examined 24 to 72 hours after welding has been completed. This is due to delayed cracking of hydrogen. As you can see here, the type number of test specimen on table 210. Service welding procedure qualification. So wall thickness, how many tests are required? Hardness, metallography, nick break, and this. And so you might be asked questions that you need to refer to this table. So please study this table, and then the location of this shows when you do the bend test for typical in-service weld. You see this 1.6 millimeter. It should be machined here. So when you apply the load on a bend test, you should not see any crack here. So because this shows the ductility of the metal, the bend test. So weld build-up, overlay, and clad restoration. Repairs to weld overlay or cladding can involve replacement of the entire thickness of the cladding or weld overlay or partial thickness. Weld build-up refers specifically to the application of carbon steel or low alloy weld metal and applied for the purpose of restoring base metal thickness. An effective depth means the depth below the finished weld surface where metal chemical analysis is performed. More than one layer is required when temper bead technique are used. So this could be a potential question. Number of weld layers in production shall not be less than the number of layers deposited for weld overlay procedure qualification test. So number of weld overlay is an essential parameter. This could be a question. Minimum depth of weld overlay or back cladding shall be 3 millimeter or more in thickness. So minimum weld overlay is 3 millimeter. Potential exam question again. When the strength of the original base metal to be restored by weld buildup. The weld metal tensile strength should be equal or exceed. So this is a common sense that of base metal. Consideration should be given also to the differential thermal expansion between the base metal and weld overlay. Because of the thermal difference, there can be contraction and expansion and thermal stresses there. So the possibility of galvanic corrosion should also be considered, especially at the age of high alloy or non-ferrous weld overlay. And surfaces to be welded shall be free of rust, scale, again, paint, coating, and other contaminants, and shall have a smooth contour. So this, because repeated many times in all these articles, so this could be a potential question. And if surfaces are to be prepared by blasting, media should be free of silica that would interfere with subsequent welding operation. And silica could create cancerous, and so should be special precaution even taken from safety point of view, and could also the residue of the silica could make a weld defective. And typically semi-automatic welding process such as gas metal arc welding used to maximize productivity and minimize heat input. In general, heat input shall be minimized to prevent burn through and distortion. So it's very important that we take care of the heat input. Any subsequent suspected area of cross-contamination shall be etched with a nitric acid or copper sulfate solution to confirm the location of glass substrate interface. They might ask what sort of solution we use. As you can see here, there are two figures, and they show how you prepare the area. And look at these numbers, the 6 millimeter away minimum, the angle 45 degree that you machine off, and then you do the weld, and it shouldn't be the reinforcement more than 1.5 millimeter maximum. So please look at this and memorize this. And this, if they ask you, mostly it will be an open book question. Prior to back cladding butt weld, cladding shall be stripped back a minimum of 6 millimeter, as we said, and dehydrogenation heat treatment or intermediate should be considered post-weld heat treatment, especially if base metal is 2.25 chrome or heavy wall greater than 1.5 inch thick. Non-destructive examination before welding, such as magnetic MT or PT, may be utilized to ensure that defects are completely removed. Welds on base metal over 9.5 millimeter 3x8 inch thick should be examined by volumetric examination, such as RT or UT. And after removal of any damaged stainless steel weld overlay and prior to applying new weld metal, carbon steel surfaces should be examined with copper sulfate solution, again to verify complete removal of stainless steel. So if you apply copper sulfate solution, the color changes, and then you know that there is still stainless steel there on the base metal, which is like low alloy steel, carbon steel. Final surface of weld overlay, back cladding, weld joints attachment to weld overlays or integral cladding should be liquid penetrant, PT tested to up to extent, and the chemical composition at the effective depth of the weld overlay or back cladding should be included in welding procedure specification tests, such as for right number of say 10% or 5 millimeter depth. So because these are essential parameters. The right number, you know, normally they say, okay, it should be say 5, 10 or whatever, and that right number helps actually the welding. Right testing of austenitic stainless steel weld deposits for type 304, 34L, 316, 316L, which means low hydrogen, and 317L low hydrogen. Ferrite number should be 4 to 10. They might ask you what should be the range of ferrite number. And ferrocyanide test should be performed. 100% of finished nickel copper nickel overlays and back cladding deposit. The results should not indicate the presence of free iron. So ferrocyanide is detecting the presence of free iron on a nickel copper or copper nickel or alloys. And solvent or detergent solution should remove oil, grease, dirt, again here for welding purpose. A pickling solution may be used to remove oxides. So how to remove oxides? One of the solutions is a pickling passivity. Inspector should be consulted to establish the need for hydrostatic testing of equipment after repairs are complete. So it is recommended that the inspector should have a say on it, whether hydro is needed after the repair. And pressure testing is generally not needed for well build-up and restoration type repairs because you're not doing a true thickness. So this is generally the case. Fitted welded patches. Repair methods typically apply to pressure retaining shells that have suffered local wall thinning, including through wall, and due to erosion, corrosion, or other local damage mechanism. Repair methods generally suitable for service temperatures above the nil ductility temperature of the material of the construction up to a maximum temperature of 345 degrees Fahrenheit or 600 degrees Fahrenheit or 345 degrees centigrade. So it should be above the nil ductility because if it's below the ductility and it's a brittle phase, we might have trouble. This repair method shall not be used when the damage mechanism, extent of damage, or likely future damage cannot be characterized. So we don't know what's the metallurgical structure of that and how the damage is happening. So it might. And remember this, weld joint efficiency factor is 0.55. And look at this picture and please see the corner radius 3" here should be minimum. The nozzle is here and you're putting 2 patches here. And this is a typical area where the damage happens. So you're putting a fillet welding all throughout. And the setback here between nozzle and plate, the L minimum. So corner radius of fillet weld patch is 3 millimeter, as we said, and parts to be fillet welded shall be fit as tightly as practical to the surface to be welded. No event shall be separated by more than 5 millimeter. So this can be a potential exam question. When you put the patch on it, there should not be more than 5 millimeter between the actual surface and distance done and actually the patch plate when it is on it. Post-weld heat treated. If it required, examination shall be performed after the application of post-weld treatment to ensure any crack growth as a result of stress relaxation is detected. So always remember the NDT is always done after the post-weld heat treatment, and then the hydro test is done, or if it's required. The pressure component and installed patch plate should be leak tested. So you don't need a hydro test, you just need to see that it's leak proof. Paint, scale, rust, liquids, again, and other foreign material should be removed from the weld zone, and area not less than 40 millimeter on either side of the weld. So 1.5 inch. So what would be the area? Would be 1.5 inch from each side of the weld. It should be clean. And repair welding consideration for chromium molybdenum steel pressure vessel. Sleeve repairs. We just put a sleeve. This for a pipeline, but this was much a clearer picture. So you see how these sleeves were 2 half sleeves, and then they're bolted together. So the same can be done on a pressure vessel or a piping. Sleeve repair and partial patch repair methods are normally applied temporarily, not recommended for periods beyond the next upcoming shutdown. So during the shutdown, normally you change them. Welding bevel surfaces shall be clean, dry, free of oil, paint, or other contaminants. To prevent hardening of metals, weld is less than 2 inch in length should be avoided. So if you're doing a weld bit, it should be at least 2 inch or more. When the material is severely embrittled, a de-embrittlement heat treatment operation may be used to recover toughness of material, and dehydrogenation heating shall be carried out at a minimum of 300 degrees centigrade, 570 degrees Fahrenheit for a minimum of 1 hour. And the entire area of pressure vessel that is to be repair welded shall be examined by means of visual examination of VT. Complete NDE, performing the area that's at least the maximum either 2T, where T is the thickness of material, or 100 millimeter or 4 inch from the edge of repair welded, preheated, or post-weld heat treated area to ensure the area is free of defects. So again, this is 4 inch or 2T. Pressure tests, when required, shall be performed at a temperature higher than the fracture appearance transition temperature and at or above minimum temperature. So most onerous condition. This table, please have a look at it. So it's a typical in-service degradation. It says the type of material, what sort of problem you might have, and at what temperature, and what type of damage you might have. And here there is a typical example of damage to a pressure vessel at the nozzles, and then normally, as you can see, it's all when there is a change of shape or there is a welded area, circumferential welds. And this is a good indication reference here. And typical preheat interpass temperature, this table might be used as a calculation type of question. They might ask what sort of steel, which P number, and they might ask you, okay, what would be the preheat, minimum preheat or maximum interpass. As you can see here, always the maximum interpass is 300 degrees centigrade or 600 degrees Fahrenheit. The preheat starts from 120 to 200, or normally 100 to 200, so 250 to 400, say 390. Welded hot taps. Hot taps in pressure equipment or pipeline. So hot tap is when you're drilling a hole or adding a connection to it, and then a spool or a nozzle while the equipment is in service or under pressure. So this Article 216 provides requirements for design, installation of fittings by welding on equipment while in service. And hot tapping is used to install a branch connection to piping, pipelines, pressure vessel, or other pressure equipment and storage tanks while the equipment is in service. The drilling machine should be thoroughly inspected before being operated to ensure that the critical parts of the machine are not worn to the extent that they might fail during the hot tapping operation. But this makes sense. So this is how it works. There is a You blind this, there is a gasket here, there is a nozzle here, and then the valve is blinded, and then this is bolted, the actual drilling machine is bolted to it, the valve is opened, and then the drilling done, then it gets retracted, and then again it's blinded, and then another nozzle added to this, and then that connection is made. Conditional application for which hot tapping not recommended. Material requiring post-weld heat treatment after hot tap welding, and when alternative welding methods are not acceptable, hot tap should not be located on weld joints where installation on an existing weld seam cannot be avoided. So it shouldn't be done on a weld seam, and hot tap should be a full encirclement sleeve. 2/2 when the ratio of diameter of branch connection to the run pipe connection is greater than 0.7. So the ratio, if the ratio between the connection and the main is more than 2/3, it should be 2/2 sleeve. Probability of burn through increases when welding components are less than 1/4 inch thick. And to minimize the risk of burn through for such welding components, the first pass should be made with a 2.4 millimeter. This could be an exam question, or a smaller diameter electrode. So use the smallest electrodes, so there is no burn through, because not much heat input or melting of the base metal during the welding. Calculate the wall thickness T available to contain internal pressure as below. So T is equal to measured wall thickness minus 2.4 millimeter, because that's the electrode you're going to use, say. And low hydrogen consumables, and that T, which is the actual thickness, T, the measured wall thickness minus 2.4 millimeter is The T, you remember, this is a design required thickness. You shouldn't be, this T that you calculate shouldn't be less than the required design thickness. Low hydrogen consumable or electrodes or fillers should be used. As usual, the area to be hot tapped in the vessel or pipe shall be UT examined to determine any defects on the existing plate or pipe wall. Area to be hot tapped should also be MT or PT to check for surface defects, and the weld seam should be subjected to 100% volumetric examination and 100% surface examination, MT or PT, of the external surface in the area of hot tap, and then 3 to 4 inch on each side of hot tap to ensure there are no detectable flaws such as lamination in the area to be welded. Cutting equipment should be subject to a pressure test prior to hot tap cutting, because if they leak during the hot tap cutting, we're going to have a problem. To ensure that the equipment has no leaks when under pressure. For operating temperature of vessels pipe in the range of 0 to 90 degree, water should be used to perform a hydrostatic test. Flow excavation and weld repair, depending on the type of location of the flow, the type of base metal or weld metal material, excavation can be accomplished by mechanical removal methods such as grinding, machining, lapping, honing, or flapping. And abusive grinding should be avoided because it creates a fatigue. It reduces the fatigue strength or premature failure during introduction of large surface residual stress and stress risers. And grinding or cutting consumable used on carbon or low alloy steel material will become impregnated with residue of those material and become unsuitable for use with austenitic stainless steel. And surface contamination of austenitic stainless steel with carbon or low alloy steel residue can result in surface corrosion or pitting of austenitic stainless steel. Flapping, which is actually a polishing, should only be used to smooth or polish a surface. Flapping is not suitable for removing defects other than superficial surface blemishes. And this is the flapping. And 3-to-1 taper is not required when the cavity will be filled with weld metal. Here you can see excavation and weld repair of that. So you remove that weld, it's like a boat shape, and then you fill it. Boat shape is a very good approach for welding and for access. When thermal gauging by arc, carbon arc, plasma arc, because a very rapid heating or a molten temperature and subsequent quenching to ambient temperature can harden or brittle heat affected zone, and this thermally heat affected material should be subsequently removed by mechanical process such as grinding. This repair technique applies well to local defects. Where damage is extensive, such as general stress, corrosion, cracking, or stainless steel, replacement should be considered. If after removing the defect, the remaining thickness is more than the minimum wall thickness plus the corrosion allowance, then obviously you don't need to weld it to fill the gap. Just smooth out and excavate the area with 3-to-1 taper to reduce the stress concentration because of change of shape, and leave it as it is. But if remaining thickness is less than the minimum required thickness plus corrosion allowance, then wall thickness should be built up by welding. So this is common sense. Either during or after defect removal, the excavation shall be shaped to provide adequate access for the welding operation, and that both shape we show you in picture, in order to facilitate proper fusion and to avoid slag entrapment or lack of penetration. To minimize weld shrinkage stresses, the width of cavity should be only as wide as needed to ensure defect removal and to facilitate welding as previously described. So if it is very wide, you will have a shrinkage problem because there would be a wide area of molten metal. If the excavation is performed using a thermal removal process, then grind it off by additional 1.5 millimeter 1/16 inch after you did the thermal removal, because as we said, there can be thermal stresses involved, and also the structural metallography of the material is changed because of the high thermal stresses there. So grind it off and then inspect it before welding begins. This is to remove any surface crack, hardened material, scale, or carbon deposit. And characterize the flow, size, depth, orientation to the extent possible. If flow is a crack, the crack tip may be rounded by drilling a preclude crack from propagating during its excavation. So first, blunt the crack, reduce the stress razor. Crack is got the highest stress razor. It just works as a knife, cutting through. So blunt it and then remove it. Verify defect removal by inspecting the cavity using BT and PT or MT. And repair the cavity by welding according to a qualified WPS using a qualified welder. And then do a RTUT. So ensure that there is no possibility of flaws introduced during repair welding, such as shrinkage, crack from deep weld repairs in thick sections. Weld repairs that have fully penetrated the component should be subjected to either leak testing or volumetric examination or both following the repair, and any post-weld treatment to verify the integrity of the repair. So for full penetration, you have to do a leak test. As general rule, lapping methods are suitable only if you have a defect, shallow defect, say less than 0.05 millimeter or 2 tau or 0.002 inch. Honing is an abrasive process, and the purpose is to do a fine finish on the inside surface of cylindrical component. Machining has the advantage of cutting and forming the weld preparation with a single piece of equipment while closely controlling dimensional tolerances. And these are both sample in this figure that you can see in the shape of both hull that are cut out from the base metal weldments of heat effect and so on. Flange repair and conversion. This article applies to the refinishing of flange faces or changing the flange face finish to enable the use of different gaskets. The most important part of the flange is the surface finish of the flange contact surface, because that's essential to the leak tightness of the gasketed joint. When surface finish deteriorates in service, it can become necessary to either replace the flange or refinish the flange face. The flange may not be sufficiently thick to permit metal removal by machining and still meet the minimum thickness required for the design pressure rating. In such case, it's necessary to increase the flange ring thickness by weld metal buildup before remachining the surface. Remaining height of the raised face due to refinishing shall not be less than 0.8 millimeter. Could be a potential exam question, and flange face roughness shall not be more than 3.2 micrometer or 125 micro inch. And if post-weld heat treat after build-up is required, it should be done before machining. A flange should be marked on its edge with a letter R after repair to show that it's actually repaired, and examine each weld pass for surface defects by either MTU or PT. And after the flange joint is reassembled in the field, it should be subjected to a leak test prior to being placed in service, or an initial service leak test. So initial service leak test means you slowly increase the pressure and then watch the flange and see that it's not leaking, and then go to the operating pressure finally. So you're actually doing at the same time you're pressurizing it, and as well as doing an in-service leak test. An initial in-service leak test is the one in which the joint is monitored for leakage as pressure is increased in the system. Here in this figure, you can see the weld build-up here, and you can see that it's like a triangle at the tip. So it's got maximum area of interface with the actual flange, the build-up area, and depth of the weld you can see here, and thickness of the weld. Inspection and repair of shell and tube heat exchangers. Total replacement of tube bundle when tube is inspected indicate a wall loss of 40% or more. So if it is more than 40%, then do the total replacement. Individual tube replacement when the ball loss of 20 to 40%. Consider thermal efficiency of heat exchanger when blinding some of the tubes by plugging them, and the corrosion allowance provided for the support plate should be twice the value for the shell side. So remember that it's twice the value. And typical friction fit tapered tube plug. So you just press it in, plug it. This is called friction fit. So by friction, it's actually tapered. And as you can see, diameter here is like conical and with a increasing diameter. So it goes in, the diameter increases and it fits. Prior to repair and to increase accuracy of inspection, tubes should be evaluated for need to be cleaned. And cleaning can be performed by high pressure water blasting, chemical solution, or abrasive blasting. High pressure water blasting is normally 70 MPa or 10,000 psi. When cleaning with chemical solution, caustic solution should not be used in 300 series because of chloride content in them, and it can damage the 300 series stainless steel tubes. And all tubes that are plugged should be pierced or to provide for venting and draining. When doing so, vertical tubes should be pierced at each end, and horizontal should be pierced on top and bottom of the tube. Mechanical plugs should be used for pressure up to 50 MPa, 7,000 psi, since friction fit tapered plugs are suitable for pressure only at 1.5 MPa or up to 200 psi. So if they say this can be a potential exam question, if it's which one you use. If it's more than 200 psi, you use mechanical plugs. And you can see the mechanical plugs here. It's got several rings here. So several zones that it can protect this. And you just screw it in here. And it's got several rings. So even if one leaks, the other, like the fluid goes through, still there are two other rings who can hold it. And this is how they screw it in. Typical installation mechanical fit tube plugs on a heat exchanger. Plug map may be developed to record the number and location of tubes that have been plugged. An examination of heat exchanger typically covers three areas: external, internal, and tube bundle. Not necessary for each inspection to have the same frequency. And remote field eddy current, generally used for inspection of ferromagnetic tubes. Ultrasonic examination system designed to measure tube wall thickness may be used for a small heat exchanger where damage is localized or for validation of other NDE results. Surface examination by PT shall be performed at the completion of weld repair, and the following minimum number of tubes inspected should be considered. So if you have 50 tubes, or 25%, if you have 500 tubes, if you have 750 tubes, you have to do 20% of them, or 500 tubes. Then if 15% of tubes for heat exchanger with a total count of 750 tubes up to 1,000 tubes. So that means, say if you have 1,000 tubes, you do 15% of them, 150 of them. Maximum 750 tubes, and 10% of the tubes if you have more than 1,000. So if you have a 2,000, you will do say 200 tubes. You check. So that is the frequency or percentage of coverage. You don't need to remember this number, just to find them during open book exam if required. And then this table, inspection effectiveness table, it tells you, say, infrared, ET, or where they are used and how much effective they are, and how many percentage of you have to use. Pressure and tightness testing of tightness of piping and equipment. Limited to use of field pressure or tightness testing of existing equipment piping, either using either of the two fluid medium, liquid or gas. Um, this article actually addresses pneumatic testing, and pneumatic is potential more hazardous than hydrostatic due to higher level of potential energy in the pressurized system, because the gas is compressible and it stores a lot of energy. So all reasonable alternatives shall be considered before this option is selected. Try not to use it if you can avoid it. And closure weld is the final weld. Some definitions here: connecting piping system or components that have been successfully pressure tested in accordance with the applicable construction code. Sometimes when you do on the field, you do the last weld, and then you cannot. That's called the closure weld. Some people call it golden weld. And because you cannot pressure test that one, then you do full RT and UT and even MTPT to make sure that you can verify the tightness and the integrity of that joint. Hydrostatic test, a pressure or tightness test where liquid, typically water, is the test medium, and in-service leak test, a test using the process medium of the pressure equipment performed at the start of the equipment. So as we said, you just watch it, slowly pressurize it, and then go and then watch if there is no leak. If there is a leak, stop the pressurization, and then find the leak, repair it, and then do the same thing. Pneumatic test, a pressure or tightness test where a gas, generally nitrogen or air, is the test medium, because they're not flammable. Nitrogen, for example, they are frequently used. Pressure test may be performed with liquid, hydrostatic test, gas, pneumatic test, or a combination. They call hydro-pneumatic test or a squeeze test. Primary purpose of performing a pressure test is to verify integrity of pressure system. So this is the primary purpose. This could be a potential exam question. Hydrostatic pressure testing can provide some mechanical stress relieving. This is accomplished when the local region of high stress, such as the stress concentration and crack-like imperfection, undergo local yielding during the pressure test. As stress relieving is because of local yielding during the pressure test. And tightness testing may be considered when a structural integrity does not need to be verified, but leak tightness must be verified prior to startup. So tightness is not verifying the integrity; it's just telling us whether it's tight or leak-proof. Pressure test of equipment or piping system should be considered if an alteration or repair has been performed, the equipment has been re-rated, and needs to be recertified to determine integrity. So these are the three conditions they say, like as an example, when you do the pressure test, when you do the alteration, re-rating, or you want to recertify to determine the vessel or the pressurized container. Pressure test may not be required for re-rating equipment using a higher allowable stress, since the original pressure test may be higher than the test pressure required for re-rating. So if you're actually derating it, then you might not need to do a pressure test, because it's already been pressure tested as higher during the construction phase. Pressure testing or alternative tightness testing should be considered during routine inspection after cleaning operation, where the integrity of the tube-to-tube sheet joint is in question. And pressure testing should be performed hydrostatically unless one of the conditions apply. For example, the equipment or piping or supports, including foundation, cannot support the liquid, the weight of the liquid, or the piping equipment cannot be dried, and traces of the test liquid may result in contamination of the system or its content after returning to service, or when the equipment or piping contains internal lining that could be damaged by the test medium. So this condition, as an example, it brought when if this condition are not present, then you should definitely go for hydro test. Otherwise, if you're forced, then that's another matter. You have a trouble, with one of these conditions as an example. Non-destructive examination may be considered in lieu of pressure testing to verify repairs or alterations. It's like a closure weld or final weld. When visual examination is not possible with underground piping, monitoring of system pressure for pressure drop during tightness of in-service test may be substituted. So this is quite clear. In order to reduce the risk of brittle fracture during the test, temperature of the metal during the pressure test should be maintained at a minimum of 17 degrees centigrade, 30 degrees Fahrenheit above the minimum desired metal temperature. This is to avoid any brittle fracture during pressure test, and this is coming from ASME section 8. And when pressure testing piping system, the ambient temperature should be greater than 2 degrees centigrade or 35 degrees Fahrenheit. Potential exam question. And pressure testing should be completed prior to installation. So it's always done before installation, because installation can mask any leak. It is not required for the inspector approving the hydrostatic pressure test to be certified per SNTC 1A or leak testing or visual examination. However, the inspector should have the authority to stop the pressure test when deemed necessary to do so. So it's exempting the inspector. Although the inspector is the authority, he is not necessarily needs to have a ASNT level 2 or 3 visual test. If the test of the piping exceeds the test pressure of the vessel test pressure can be used, provided it is at least 77% of piping test pressure. Other the piping should be isolated and tested separately. Test water for austenitic stainless steel should have chloride content of less than 50 ppm. Following a hold time of minimum 10 minutes, the pressure should be reduced by 30% or to internal design pressure, whichever is lower, or maximum allowable working pressure for a visual examination for evidence of leaks. And locations such as flanges, weld joints, threaded connection, etc. And test liquid should be drained immediately after completion of hydrostatic test, and pressure vessels or piping system that will hold the test water for more than 10 days should be treated with corrosion inhibitor and biocide. And the fabrication and in-service inspection record along with necessary operational records should be reviewed prior to testing to determine if the pressure component system has experienced a credible deterioration mechanism. And there is a sample of test records to tell you the location, system, tag number, equipment identification, what type of test done, hydro, service, pneumatic, combination hydro, etc. And then test media and what was the test pressure, and which drawing it was used from which point to which point the test was done. Non-destructive examination in lieu of pressure testing for repairs and alterations. So this article applies to equipment for which NDE provides better assurance of integrity in future operation for elevated temperature cyclic operation where crack initiation propagation is a concern. Large flows may not result in failure during the pressure test, but may propagate in cyclic or creep service. Pressure test is not practical. When it is not practical, an NDE can be shown to provide appropriate integrity, and a pressure test is practical, but NDE can be shown to provide equivalent integrity assurance. So practically it's cheaper to do then, and it's safer. Fluid use is typically water for hydrostatic test and pneumatic test. This is performed in some situation where the presence of any water or weight of water in the system is an issue. So it cannot support the weight of the pressure, the water when it's pressure tested. Pneumatic test is potentially hazardous due to stored energy of compressed gas. Performing pressure test of an in-service or component with inadequate fracture toughness could result in brittle fracture. Once a device or component has been subjected to a one-time but new construction hydrostatic test, any additional hydro test over the life of the component will serve minimal useful purpose regarding structural integrity or benefits of the redistribution of service. So this redistribution of service is only done through the initial pressure test. If you cannot do it again and again, the pressure test to start redistributing. It's just done once. It just happens once. Painting coating lining could mask leaks that could otherwise have been detected during the pressure test. This includes damage to refractory or other insulating materials, internal material, as well as damage to internal linings. Thanks for listening. Again, I would advise you to look at the PCC2, all these articles 201 up to 502, according to the publication effectivity and body of knowledge. We have also brought 6 sets of flashcards plus 100 mock exam question, but please read the actual ASME PCC2 when you're solving our mock exam questions, so you know how to look for. Out of the 7-8 question, quite a few could be from the as an open book question.